Okay, welcome everyone, and thanks for joining. We got quite a big crowd this morning. Sounds like a Red Hat OpenShift is a hot topic, and so this morning we do have a handful of experts from Red Hat, including our own Director of Alliances, Vic, who will give us a quick introduction, and then from then on we'll turn it over to Phil. And Phil will, get into, OpenShift and tell us how OpenShift works with GitLab. And if you have any questions, I'll put the document in the chat. You can put your questions in that document, or you can put them in the chat, and I'll move them later on into the document that you have in the meeting invite. So without much further ado, I'll turn it over to Vic.
Thanks, and thanks again for this opportunity, right? So I want this session to sort of focus on the technical product integration that we have done with our operators. So we have Dylan, who's a product manager leading this effort, and Mitch, who is here as well to kind of help us understand what we are building for OpenShift. And I will just kind of turn it over to Dylan and others in his team, including Mitch. Now, we have invited quite a few Red Hat team members as well. So maybe the suggestion here would be, let's start with the GitLab operator exploration and demo, and then Phil, if there are any follow-up questions, we can then step into OpenShift specific items.
Okay.
So if that works, I don't want to take any thunder away from our product team. So Dylan, I'm going to pass it on to you.
Sure, sounds good. Thanks, Vic. So yeah, I'll do a pretty brief presentation, just kind of highlighting the basic overview of our operator. Mitch will jump into the demo. So I'll go ahead and share my screen, and I've also shared this presentation in the agenda. This is just, again, a very basic overview of how we have connected the dots and allowed our instance of GitLab to actually run on an OpenShift container. That was really the true kind of purpose of our operator, at least initially, was we wanted to enable folks to run an instance of GitLab in a Red Hat OpenShift container. So I'll save this piece for later, after we do the demo for Phil and other Red Hat folks to talk about, the benefits of Red Hat OpenShift. But I did want to get into what kind of operators we currently offer. So our self-managed applications can utilize, our server operator, which we recently created, and our runner operators, and to serve kind of different purposes. The runners are going to be, executing pipeline jobs and sending those results back to the instance of GitLab, whereas the actual server operator is intended to manage the lifecycle of that instance of GitLab running in OpenShift. And again, like I just said, both of them are operators, so they are intended to manage the lifecycle of both of those two use cases. This is just a very basic overview of operator characteristics and how they relate to our GitLab server operator. Basically, install and configure GitLab instances, in a more repeatable fashion for our cloud native installation. Basically enjoying, seamless upgrades from version to version. This could be a challenge for businesses, keeping up to date on the most current version of GitLab. And so the operator kind of allows you to do that in a much more smart fashion. And then as we move forward, the last three bullets are kind of forward thinking. So these are, our intended direction. Backup and restore characteristics. We want to, offer monitoring and better metrics and visualizations using Prometheus and Grafana, and then kind of moving into advanced auto scaling as we upgrade our maturity of the operator. This is a great graphic from the operator framework website, which I have right here. And this is kind of where we intend to go, and a basic overview of kind of where we're at. So I would say right now we're just kind of dipping into maybe level 3 as far as the maturity goes. And I would say we're kind of more truly in level 1. And then we intend to kind of take this as far as we can go as it relates to GitLab. So if we can go and have this kind of autopilot phase of our operator maturity, we will go there. And before I kind of jump into some of these links I have above, I just want to have this helpful link slide is also included here. We've got a couple different docs, both for the runner and the server operator. And I've got a couple contexts there. A demo, which obviously we're going to go through the demo today, but there's also a video that Cesar recorded. And then we've got our generic operator epic. So going into some of the things that we're working on right now, this is the official Red Hat operator certification that we're currently going through. So this will allow us to list our operator in the marketplace. So just another bypath for folks who want to download the operators, the GitLab server operator, and utilize it for their distributions in Red Hat OpenShift. And then this is a overview of our next release. So we have done our GA of the operator, and this is where we intend to go for our next update of the operator. Some of the things that we're working on include, like I mentioned, the operator certification, but also enabling near zero downtime upgrades, which I know a lot of customers are very interested in, and even more parity with our Helm chart. Currently, we offer parity with all production kind of characteristics of our Helm chart, but we want to take that even further and kind of have full parity with our Helm chart, which I think Mitch can talk a little bit about. And then I mentioned this before, this is just the graphic I showed before, but they also go into more in-depth kind of descriptions of what each of these levels mean. And as I mentioned before, we're really in level 2, I would say right now, which is basically upgrading and keeping the operator up to date, as well as our GitLab instances. So these are the docs, which I think Mitch is kind of going to touch on and go back and forth with. And then this is our video that Cesar recorded. So now I'll kind of toss it over to Mitch and he'll jump into the demo. I'm also happy to answer any questions after Mitch is done.
Thank you, Dylan. Hello, everybody. Let me get my screen shared here. So like Dylan mentioned, I'll run through a quick demo of the operator here. I can also give kind of a brief overview of what operators do under the hood and why they're important and helpful, especially in relation to the GitLab Helm chart that has been out for years at this point. And why the operator might be worth considering. Feel free to stop me at any time and I can clarify anything that comes up. So I saw a question in the chat, which is actually a good place to start. What is the general concept of an operator? So just getting a little more detail to what Dylan was talking about. The operator is effectively a way of deploying a Kubernetes native application. So I'll compare it to the Helm chart to maybe give some context. So with the Helm chart, what we do is define basically in Helm's templating language what objects we want deployed to the Kubernetes cluster. Those objects are things like deployments for GitLab Web Service and GitLab Shell and Sidekick and Task Runner, now called Toolbox, as well as stateful sets for things like MinIO and Postgres, etc. And so effectively, based on what settings and parameters you pass to the Helm chart, it will render out the template of objects to apply to the cluster, and you send it in a one shot up to the cluster, and Kubernetes will ensure that all those objects exist. Now, the operator is more powerful in the sense that it's actually a long running process in the cluster. So it has an active connection to the Kubernetes API server and can ensure your desired state over time. So for example, if I were to deploy the Helm chart and then manually went in and for some reason deleted one of the deployments, it would just stay gone until the next time I run Helm install. Whereas the operator would receive that event and recognize that the desired state was not met and could actually reapply that deployment and ensure that it's running. So this gives us a lot of exciting opportunities because with the Helm chart, we're effectively limited to whatever we can provide to the cluster at install time or upgrade time. Whereas the operator having a live connection to the cluster, we can do things like actually ensuring that the secret that you specified exists in the cluster, or we can check storage based on the GitLab API, and just start doing a lot more advanced things like that, especially in relation to, hey, we noticed that you wanted this specific configuration, but it's not reaching its state in the cluster, and we can start printing helpful log messages or status events that make it much easier to actually debug the application because we can actually program in that administrator knowledge in code and actually deploy that for the end user. So here's our code base. It's under the Cloud Native group at the moment. And so most of the code base is in Go, as most operators are. What's great about this is that the concept of operators uses a controller under the hood, and controllers are one of the core concepts of Kubernetes. So if you're using Kubernetes, you're actually already using controllers. For example, there's a built-in deployment controller. You effectively apply a deployment spec via manifest, and Kubernetes deployment controller will ensure that those deployments and pods are running as expected. And so that's why this is so worthwhile from our perspective in terms of development, is that we're using basically first-party implementations of this concept. And this is effectively how upstream Kubernetes writes their logic for their various controllers. And so, like Dylan mentioned, we have our documentation up here in our docs site. Overall, what we're looking here in terms of prerequisites are an existing Kubernetes or OpenShift cluster. Today I'll be using Kubernetes cluster, but we deploy it the same way to OpenShift. We've got 3 different versions of OpenShift in our CI that we test against. We deploy it effectively the same way. You also need an ingress controller. We have one bundled, but of course you're free to use an external ingress controller as well. And then you'll need a certificate manager in most cases. And for today, we'll use Cert Manager, but you can also bring your own certs, and a metrics server, as well as DNS. So a lot of these requirements are effectively the same as the Helm chart. The reason for this is that under the hood, we're actually rendering the Helm chart based on the configuration that you pass. And the main reason for that was just development speed. Rather than redefining all the logic and objects in the operator, we can actually just pull in the GitLab Helm chart using Helm's Go SDK under the hood, which has been a huge help in terms of speed of development. And the other benefit of that is, as you can tell from our example here, all of the values that you pass to your Helm chart today can effectively be copy and pasted into this custom resource that we've built, basically teaching Kubernetes how to work with the GitLab object, basically telling it what a GitLab is and ensuring it's running as intended. And so very quick to kind of take your existing Helm chart installation and mirror it into an operator installation because of that commonality under the hood. So moving on to installing the GitLab operator, what I'm just going to do is I'll grab the latest released version, which we have right now is 0.20. And effectively what we're doing here is just applying a manifest. This, I think I actually have a copy of it here. So it's effectively a manifest defining the custom resource definition. This is what tells the GitLab, the Kubernetes API, what a GitLab is. And then throughout, it's a very long file, but the rest of it is effectively all the RBAC permissions for the operator to run, as well as the deployment itself, which is where the operator runs as a pod as part of a deployment. So we'll follow the instructions here. Effectively, we're just making it easy to grab the correct release artifact of that manifest. If you're on OpenShift, you would effectively just set platform to OpenShift. The difference in the manifest is there's some additional RBAC permissions for the Nginx ingress controller to run in OpenShift due to security context constraints. I already have the namespace created here, but it's empty. So we'll go ahead and apply the manifest. And my terminal wants to escape these characters. Move my zoom bar.
Sorry, Mitch. You're setting the platform to Kubernetes. Is that right?
Yep, just for this demo,
OpenShift.
I happen to have a Kubernetes cluster that I use for both operator and charts testing. I try to keep my clusters to a minimum, given they're so expensive, but the only difference in the installation for OpenShift is that I would set platform to OpenShift, and it'll grab the release artifact for OpenShift, which is the same as the one for Kubernetes. It just includes additional RBAC permissions for Nginx. And so now I've got this pod running here, GitLab Controller Manager, and you can see in logs it started up and is listening for me to apply a GitLab instance effectively. So I have one here, and what I've specified is other than the values that you would typically specify in your Helm chart, which are here under spec.chart.values. The only other one you need to supply is the chart version. So there's a mapping effectively of chart versions that are supported for the operator. And each version of the operator, we support 3 chart versions, the 3 latest minor revisions. And that way you have an upgrade path. So for example, I could install 5.4.2 now, and as soon as it's installed, I would effectively just edit this file to 5.5.0. and apply it to the cluster, and it would install that version of it. And we've got those versions tracked here as well. So all I'm going to set for this demo is my domain. I'll connect it to my external IP just because that's static and I don't have to go into DNS and update the entry for whatever IP it happens to pick. And then I just set my cert manager email. So I effectively just apply that manifest to the cluster. I'll use Stern here to watch the logs. And you'll see that it's reconciling GitLab. I can make this full screen. And it says the current version is nothing because it's not installed, and the desired version is 5.4.2. Rendering new template, looking for a designated chart, specified directory. So effectively now it's taking all those values that we passed to the GitLab custom resource, and it's rendering a Helm chart template using those values. And then effectively we have a bank of Kubernetes objects that we can apply. But the nice thing now is that instead of just applying them all at the same time like the Helm chart does, we can actually do it in a smart way. So this is why already the operator has more functionality than the Helm chart in terms of more advanced processes. So because we have this upgrade logic, we can actually run through the upgrade cycle for GitLab. So effectively that means we reconcile the new deployments at the new version, but we keep them paused. And then we can run pre-migrations. And once those are done, we do a rolling update of those deployments. So the new web service and Sidekick and Toolbox versions come up, and then we run all migrations, and then we just make sure everything's cleaned up and ensure that all the migrations passed. And so that's typically something that an administrator would have to do by hand, jump into the cluster, scale down the deployments, run migrations by hand, etc. And now all the administrator would have to do is change that file to the desired version, and the operator will handle that logic. Which has been really fun because now it's very easy to test upgrades, and when anything fails, it's very verbose in what went wrong, and it's all Go. So it's much easier to write and test in most cases than the Helm templating language, which has been a joy to develop in for sure. So it's going through the process now. It's running migrations, and then the rest of the deployments will come up. Any questions at this point?
Hey, Mitch, this is Andy from RedHat. I wanted to jump in real quick. So I noticed Cert Manager is one of the components that gets deployed as part of the Helm chart. But I was curious whether you have any plans to leverage the like OpenShift ingress router to use something like edge termination for TLS connections instead of requiring Cert Manager as like a hard requirement.
Yeah, fair question. So it's actually not a hard requirement. It's just what we recommend for most installations, and it happens to be bundled with our GitLab Helm chart just for ease of use. But you can absolutely bring your own certificates. If you search for, I believe we've got documentation here. Yep, TLS options. So you can effectively do Cert Manager and Let's Encrypt, or you can do an external Cert Manager, which is what I have here. We don't bundle Cert Manager with the operator. All I did was basically apply the latest release of Cert Manager using the kubectl apply command. No special configuration there. Or you can use your own certificate. So you can actually bring your own. Effectively, what you do is, however you generate your secret certificate, just upload it to the cluster with a certain name. And then in the Helm values, you effectively just give it that secret name to use. So global.ingress.tls.secret name. So however you can get secrets into the cluster that have those certificates, they can be used by either the operator or the Helm chart.
Okay, cool. Yeah, that's really good because I feel like some of the experimentation we've done internally with the GitLab server operator has been kind of contingent on deploying Cert Manager. And, so we typically we do a separate installation of Cert Manager, which in and of itself has, some upgrade related inconsistencies. So we find that sometimes there's like a problem with the bundle when we try to install it as an operator or something. So, I think finding more configurable ways to have lightweight installations of GitLab server is desirable. So thanks for pointing this out.
Yeah, absolutely. I would say the closest you could get to saying it's a hard requirement is that there's a webhook on the operator that is required, so that when you actually apply that custom resource, there's a webhook that receives that event. And so the way that the operator SDK and KubeBuilder configure that is assuming that Cert Manager is there, because it effectively will generate a certificate for you. in front of that. To my knowledge, you can still replace that, but all of our default configuration just uses whatever came out of the box with those frameworks. So
yeah, that's what I thought. Was because I think still, and correct me if I'm wrong on this, but the process for doing the installation in OpenShift requires you to manually apply the custom resource definitions and RBAC stuff into the cluster as opposed to installing from Operator Hub.
yeah.
And I was looking at the CRDs and stuff, and it looks like Cert Manager is pretty pervasive there. Like there's an expectation that's going to be there. So I guess that is the thing that maybe it is the webhook that it seemed like that was sort of unavoidable.
Yeah, great point. We actually have this tracked in an issue. We actually want to document the process for A, how we implemented Cert Manager and when it's actually required, and B, if you want to replace it, how to do that. So we've got an issue for that. It's marked for scheduling, so hopefully we'll get to that as soon as possible. We've had a pretty good experience with Cert Manager so far, but obviously the point is to be as flexible as the Helm chart, and so bringing whatever certificate management tool you want will obviously be a priority.
Right on. Thanks. I appreciate it.
Yep. Also, if you ever get the time and you want to open an issue for those issues you've been having with the Cert Manager installation, it'd be helpful to open an issue here and we can keep track of it, even if it's not necessarily GitLab operator's problem. It's just nice to know what folks are running into when they're trying to install it.
Okay, cool. Yeah, we'll do.
Cool. Thank you. Alrighty, let's check in here. So all of the components are running. I see web service is up. And now, so for example, I'll show you kind of this concept of how this is kind of a built-in concept. So right now I'm listing pods. If I lose my, so let's go list deployments, for example. So here's a list of all the deployments that are running in the cluster. You can do the same with stateful sets, right? Now I can actually list out GitLabs. So because I applied that custom resource definition telling Kubernetes what a GitLab is, it's now like a first-party object in the cluster. And so when I did the kubectl apply and then my GitLab manifest, this is what was created. And now if I describe it, I can see, let's go to the YAML version of it. So here's my chart values that I specified before. Here's some status conditions. So this is what we can push from the controller, the operator itself, basically giving status events. So if the upgrade failed, for example, we could push an update there explaining that it failed and why. This is exactly how you might debug a deployment. You go into the deployment and describe it, and there's events on it that you can check. In this case, there's none because nothing went wrong. Over time, we want to add more events that are descriptive of the installation process. And so effectively working with a GitLab object is just the same as you would work with any other object in the cluster. And now we can see that it's running. The last thing I'll do is I'll just show you if I were to go to my gitlab.yaml, I could jump down and change this to 550. We don't have to sit and watch the whole process, but what you'll see is that it will start printing out. So here, version information. Upgrade is true. Current version is 542. Desired version is 550. So it's going to start going through that logic of how to update. And so I can actually show you the source file for that. So here, if it is an upgrade, then effectively what we do is if both web service and Sidekick are enabled, we reconcile web service and Sidekick, but we make sure that they're paused. We pass true there. And then we can run the pre-migrations, unpause web service and Sidekick, ensure that they're running, and then run all migrations, which means don't skip post-migrations. And then do a rolling update of web service and Sidekick to those new versions. So these are steps that an administrator would typically have to do, and now it's very straightforward to just effectively write it and go, and makes it much more testable, and it's also still readable. So in the future, if we ever need to change the upgrade process or include other components in that, it's very direct in terms of how to do that versus running through it by hand a bunch of times and documenting it to be as clear as possible. So these are some of the exciting features that we can do with GitLab Operator. What's great is that many projects in the Kubernetes world use Go already. And so it's a great lower barrier to entry for contributors who want to help us develop this, which is in the spirit of open source. And like I said, much easier to write, much easier to test, and has more power now that it's a long running process in the cluster. So really excited about what we can do with it going forward. So I will pause there.
Yeah, there's a question in the chat. What do you think
Okay.
about separate GitLab components in different namespaces? Is it feasible doing it using the operator from Ricardo?
Great question. So we're actually working on that now. Let me pull up the issue board. Here. So at the moment, operators in the marketplace can either watch only its own namespace, therefore it ignores anything else that's applied to another namespace. So if I had applied that GitLab definition manifest to the default namespace, this operator wouldn't have done anything because it's told by default to only look in its own namespace. But what we can do, and what a lot of operators do, for example, the cert manager operator and the nginx operator, they watch all namespaces. But with great power comes great responsibility. If you have, cluster level scope, that comes with elevated permissions. And so what we're working on here is effectively finding the best way to be as secure by default as possible. So default to looking only in that namespace. But if you want to be able to reconcile GitLab objects in a different namespace, effectively all you would need to do is apply a separate manifest with the correct RBAC permissions. Another option is that we could give the operator that permission to do it, to manage RBAC, but like I said, that is elevated permission. And so we want to approach that in a way where if you're comfortable with that, you can enable it, but it'll probably be disabled by default. We're definitely welcome to end user input on that. I think the end goal is just to make sure that it's clear what permissions it does have and what is required to reconcile in different namespaces. Effectively, what I did as in the research here is I deployed it as I just did today. And then I tried to install a GitLab in a different namespace and just checked what failed. And it was effectively all RBAC. So there's some role bindings, roles, and service accounts that need to exist. So effectively, we just need to apply this RBAC list to that namespace. So definitely very feasible and part of what is recommended in Kubernetes in general. Just looking to implement it in the right way with the operator.
Cool. Yeah, I think we're good on our side, Vic. If the folks from Red Hat want to talk about OpenShift, I think.
Yeah, absolutely. Thanks, Mitch. Thanks, Dylan.
Yeah, Vic, I don't know that we had anything to present. I think we were just here more as support and answer questions and things like that. But that was great. I appreciate it.
Okay.
Yeah, no, that sounds good then. What I was going to say is, like I mentioned at the beginning of the presentation, the main purpose of this is there's a large appetite for folks who wanted to, were utilizing OpenShift already or wanted to, make sure that they were running GitLab in the same place as, the rest of their workloads. So, the main purpose of this initially was to unlock OpenShift for, actually running GitLab on an OpenShift cluster. So that was kind of the most exciting initial piece of this.
Yeah, and this is from the Red Hat side. It's great seeing this many people on the call. So that's really exciting to see, and appreciate the interest. And so just by introduction, my name is Mark Vincent, and I guess you could say I'm Vic's counterpart over at Red Hat, manage the partnership with GitLab here at Red Hat. So, if there are questions, that come up after the call, you can certainly reach out to me, and we can get the other folks that I work with on the partnership, try to get answers for you. Or if there are some live questions, I think there's a couple of people on the technical side on the call. You're welcome to put those in the chat or chime in. But this was great.
Absolutely. Yeah. So if you have a live question you want to vocalize,
as I say, we do have stuff we can present, so as well.
Well, I asked a question that was skipped. It doesn't pertain to the GitLab operator, but it pertains to more to the runner operator. I've been working for a few months now, and I want to voice here, Dylan, Mitch, thank you so much for all the work on the GitLab side. I've been following this closely since beta due to a need of a customer of mine. And my question pertains to from their side, one of the pending things, right? Which is official support for Podman on the GitLab runner operator. And the reasoning behind that for folks on the call is that Red Hat does no longer support Docker on Red Hat Enterprise Linux 8 and beyond, right? That's a decision. You cannot even install it, as far as I know, right? And then Podman is the official solution for building containers. And right now, customers have to jump through a bunch of hoops to try to get that to function, and it's not as stable as you would expect to be. So my question being, do you have any updates or anything we should be looking forward to that development? And I put the issue in our Google Doc as well for reference.
Yeah, Hugo, thanks for sharing. I'm only on the server side, so Darren is PM for the runner. I'll definitely pass this along. I'll send him a Slack right now, but continue monitoring that with Darren. But I'll raise this again on the product side.
Cool, thank you.
And thank you for sharing that insight from the market.
Sure.
Cool. And then Conley Rogers, so you want to vocalize your question?
Yeah, happy to do so. Looks like Mitch is actually getting into it right now.
Oh, yeah, I see it. Yeah.
So that's great. Yeah, thanks for this presentation. It is very timely. I have some customers who are able to use OpenShift, and they are using OpenShift for other applications. And so they see these announcements coming out. They're wanting to increase their scalability because they're anticipating more users coming to the GitLab instance, and the availability. They also want to minimize downtime. So I'm just wondering if you could articulate some of those key reasons why you would choose the GitLab operator over a typical cloud architecture, some of our reference architectures that we have out there, where it's more piecemeal, running all of the servers that you've got, your Postgres database, and kind of trying to maintain all of that. That way I can communicate this and help just educate them, not necessarily persuade them one way or the other, but here's what you need to keep in mind when making that decision.
Yeah, I'll take a first approach to that, and then Dylan or Vic, if you want to chime in as well, go for it. What I would say, which I was starting to type, and I'll finish that in a moment, is effectively if the way we've kind of been pitching it is that if you've got workloads in Kubernetes and you're very comfortable with it, it's typically convenient to deploy in familiar environments. And so if you're already in Kubernetes, you basically, the perk for installing the operator is all the perks that you get from using Kubernetes. So for the most part, it's, failover resilience. So for example, if these services go down, there's this built-in logic for a stateful existence that these controllers can ensure. It also makes it very simple to upgrade because it's all container runtime under the hood. And so very easy to swap out versions and A/B testing, etc. And then of course you can use all the frameworks on top of Kubernetes that are a big help, like service meshes, etc. Now, if you're not in Kubernetes, then it might not be a great pick. There's a whole level of troubleshooting and extra architecture that goes into running things on Kubernetes that requires quite a bit of contextual knowledge. But if it's there, there's huge benefits, in terms of the flexibility of those, especially the stateless runtimes. I'm going to share my screen real quick too. Part of what we've been working on with other teams is documentation around reference architectures, and part of that includes the process of determining whether you want to pick like an omnibus installation on traditional server architecture or a hybrid installation where you run most of the stateless services in Kubernetes and the stateful services on traditional server architecture. So that's part of what we're recommending here. So for example, if I picked 5,000 users, there should be a heading here at the bottom, cloud native hybrid reference architecture. So we actually lay out what cluster topology we recommend, as well as what services will be running. And then we kind of give an architecture diagram of what that would look like. And we've got that for most of the architectures, to my knowledge. And so effectively, it's just another choice. If that's kind of your environment where you're comfortable and working in Kubernetes already, it's a great implementation there because you get all the benefits of Kubernetes while putting the stateful services on more traditional architecture. And then, of course, tools like Omnibus, are similar, where it's kind of like that one-time installation, whereas this operator is a long-running process and makes processes like upgrading really straightforward. To follow up on that, I can actually check in with where we were with the upgrade process. Looks like my cluster is getting low on resources, but you can see it went through this upgrade process here. And if I list my GitLabs, it's preparing because I don't have room for that last pod. Only a 2-node cluster, but you can see the version here is 5.5.0. So it actually went through and ran all the migrations and ensured that everything was upgraded properly to version 5.5.0. Oh, there you go. We got room. So now it's running. So anyway, yeah.
Yeah. So I guess what I'll add as far as like troubleshooting and costs, the operator should be taking off some of the load on an admin. Some of those things that an admin might have to do once a month or once a quarter or even every week. Some of those small processes could be kind of offloaded onto the operator, giving the admin a little more freedom to focus on other things. And ideally, troubleshooting should be very straightforward as well, in parity with our Helm chart. Mitch just showed how easy it is to, install and use the operator to install an instance of GitLab. So ideally, moving forward, the operator is actually easier if you kind of have like that innate knowledge of Kubernetes, like Mitch said.
Yeah, that's awesome. I'll definitely take some of those reference architecture docs and use that to educate the customers asking about this. Thank y'all.
Awesome. I did want to get to JC's real quick. What is the best way to work this into a training course? I guess my question back to you is what sort of training course are you imagining, like internal or to a customer?
Yeah, thank you. So we work in the certification training program here, led by Sakamoto, and a lot of the courses that we have, like system administration, advanced system administration, CI/CD, advanced CI/CD. And it sounds like what I just heard before attending to this particular question was, this is maybe an administrator focused, administrator scoped responsibility to set up and implement operators. But is that the only type of situation where you could use operators? I'm looking at what was shared on the screen. It looks like it was an installation of reference architectures of GitLab. But are there other ways to employ operators, maybe with just IAC or things like that? Thank you for the question.
Yeah, so I would say this might be a better question for somebody from RedHat if they have a little more knowledge of operators. But there's lots of operators out there, I guess, is what maybe you're getting at. Our operator is just intended for the purpose of keeping the instance of GitLab happy and running and upgradable, that sort of thing. But there's many operators out there, and this is why we want to be on the operator marketplace, because once we're in that ecosystem with both Operator Hub and the official RedHat marketplace, they can consume and find our operator and other operators to really make their business better, I would say.
Yeah, the GitLab runner operator is already there, but like you were saying earlier, you guys are going through certification for GitLab server. There, like you were saying, there's a whole bunch of operators, and in fact, OpenShift at this point is basically itself all running based on operators. But you have all kinds of databases, you have security tools, many of our own tools, Advanced Cluster Security, Advanced Cluster Manager, they're all operators out there on Operator Hub. And they're made for people to be able to easily consume them and package them up. You even have the operator marketplace where, much like AWS's marketplace or any of those, you can actually buy it directly through OpenShift. So it's easier for customers to subscribe and buy right there.
Cool. Thank you for the response.
I just realized, I didn't do a good job. So thanks, Mark and Phil, for jumping in from the RedHat side. So let me backtrack a little bit and just kind of paint the bigger business picture and the demand that we are seeing for OpenShift, right? So Mark Vincent leads the alliances from the RedHat perspective with us. He has a couple of his folks, Phil, and others who have joined, Danielle, who are looking at accounts and how we can engage together in these OpenShift-based accounts, right? So they are great assets and great advocates for us. they have helped us, along this journey for the last 6-9 months, and helped Dylan and Mitch team kind of develop the OpenShift operator collaboratively, right? So we meet on a bi-weekly basis to build this operator. And I think what we are really excited about is getting this operator certified for OpenShift. Once that happens, we are hoping and planning to launch this product in the Red Hat marketplace once we do our due diligence, not only with the Red Hat team, but internal stakeholders. So that's the idea behind the operator. You heard very good things about why we are adopting the operator framework. And, there's a tremendous interest, from public sector side, and Chris Rahman is there to help on the public sector side. Kurt Dusek on the Alliances SA side, please reach out to him if you have additional questions. We are happy to connect you with your counterparts on the Red Hat side. So let's thanks again, Mitch and Dylan, for giving us this amazing demo. Phil, I know you didn't get a chance to present today on OpenShift. We may be running out of time, but this partnership is growing pretty well, and we look forward to working with not only the internal stakeholders, but also our amazing partners like Red Hat externally.
Yeah, I mean, since Phil is on, Phil, you want to take 5 minutes or so, just highlight your thoughts on OpenShift?
Sure. Yeah, so OpenShift obviously is our opinionated version of Kubernetes. So there is, let's see, I could jump to that part. I'll show that. All right. So if I share this, so Kubernetes is this middle piece here that provides the networking orchestration, container runtime, and packaging. OpenShift contains that plus all the pieces that we think most customers need for an enterprise level application. So it does your self-service management, your service catalog. We talked a little bit about Operator Hub. It has that build automation, deployment automation, some built-in CI/CD itself. And all these pieces together make up Kubernetes plus OpenShift. So one of the things which is probably beneficial for you guys, for some of your customers, is they're basically pretty much wherever your customers want to run OpenShift, they can. We do have managed clouds offerings as well as self-managed. So we have directly on the marketplaces with Amazon and Azure, as well as IBM, where they can subscribe to a managed offering of OpenShift, where a combination of our engineering teams and the cloud providers' engineering teams will provide the OpenShift platform infrastructure and management support for them. And then they just have to worry about running the applications they want. So then they can quickly, for example, once the GitLab server is ready, they can pull down that operator, throw it up in their cluster, and start deploying their applications without having to deal with all the background management and support of the OpenShift. Of course, we do also provide the ability for them to install OpenShift on their own hardware. If they want to manage it themselves in AWS or the other clouds, they can do that as well. They can do it on vSphere, Nutanix, a variety of different offerings. But basically, wherever they want, OpenShift will run the same. So that can help, especially when you have outages this week, like AWS East earlier, and currently, I don't know if you guys saw, but AWS West is now having issues. So it's probably going to be spurring some people to want to look at multi-cloud offerings here, I'm guessing in the next couple of weeks, once they get back from Christmas. But with things like OpenShift, and then of course with your GitLab operator, wherever they run it, it's going to run exactly the same. So they can support multiple clouds and hopefully mitigate these types of outages.
Yeah. Edmund, do you want to vocalize your question? Well, basically, Phil, Edmund was asking in the slide, there's a CI/CD is listed as a component of OpenShift.
Yes.
How should we describe how this compares with the GitLab CI/CD?
So kind of like what Mitch was talking about earlier, where with your Helm chart and stuff, you support a variety of different tools. We do the same thing with OpenShift. We do have a built-in CI/CD pipeline they can use. But of course, if they're familiar with, for example, with GitLab and they want to keep using GitLab, by all means, they can keep using the GitLab runners. They can use GitLab for doing their CI/CD pipeline. If they just want to use it as a source code repository, they can do that. So we try to be as flexible as possible, allowing customers to use the tools that they're familiar with, and so that they have as the minimum pain as possible.
Okay. Cool. All right. I don't see any other questions in the document. I think Hugo was just a comment on a previous chat comments. Any other questions?
Yeah, my comment, Tebo, I think there's a lot of conflation of concepts, right? This is hard, people. This is hard, especially for people that are not used to the Kubernetes environment. Where Mitch said, it cannot be overstated. We run into these customers all the time. They come to us, I just want to install Kubernetes. My first question is like, why the heck you're doing that yourself? It's like self-inflicted pain. Stay away from it, right? So there's a lot of knowledge that needs to be gathered and solidified, because, you know, even I'm typing this, right? Just the fact that we started talking about GitLab Kubernetes operator, and now we cannot talk about GitLab Kubernetes operator anymore. It's simply GitLab operator, right? Because of a naming issue, right? And then we start throwing Kubernetes here and there and operator and GitLab all together. I see a lot of people conflating concepts. So I think it's important to get the basics, right? Even for us technical people at GitLab, get the basics down, understand where things are coming from, understand the why behind of each concept, at least on a high level, right? And then call for help, because we all need those big brains. So thank you again, the distribution team and the product team.
Hugo, I have an answer to your question as to why people want to do that. It's because they've heard about it and it's 100% buzzword compliant. That's the only reason why. Oh, we've heard this is the latest thing, I should be doing it. That's what I've seen.
And to that point, I think that's a good opportunity to, you know, to the point of call for help. It's a good opportunity to engage with your, you know, Red Hat counterpart. You know, if you have customers or whomever coming to you, you know, as you say all the time, asking questions about Kubernetes and OpenShift and GitLab and how do they all work together, you know, that's what I'm here for. That's what Vic is there for, to, you know, and others to you know, be the link between GitLab and Red Hat and get these questions answered so we can, you know, help our mutual customer. And so anyway,
great.
I appreciate
Thanks,
this.
Mark.
Great.
Yep. All right, cool. Thanks all. We right at time 2 minutes after, but that's cool. Vic, any last comments?
No, thanks for the demo. Thanks everyone for giving us the time. And let's continue this collaboration and learning together. But there's a lot of help available inside the distribution team with the Red Hat experts. So please reach out and let us know how we can help you.
Yeah. And thanks once again to Team Red Hat for taking time to participate in this skills exchange call, and we definitely appreciate all the help and the answers that you provided. And Mark, I will most certainly take you up on that and shout out the questions in your direction.
Great, thank you.
All right, thank you all, and have a great Wednesday. hope to see you next year, actually, because we're not going to have another session this year. But if I don't get to see you, have a happy holiday, Merry Christmas, Happy Hanukkah, whatever you celebrate, during this December month, and a very prosperous New Year, especially for GitLab and RedHat. So, all right, thanks all.
Thanks.
Cheers.
Bye.
Cheers.
Bye.